Hi, I'm Allison Campbell, and I have been thinking a lot about our planet and how it's changing. And more so even today, as we get reports out of the Midwest of extreme storms forming that have the potential for a loss of life and property. And so today I'm going to visit with Brad Isom, who is a radar engineer at the laboratory, and who's going to talk to us about some of the research that he's done and how we make some of these observations. So Brad, can you tell me a little bit about yourself?
Sure. Like you mentioned, I'm a radar engineer here at PNNL. I work with the Atmospheric Radiation Measurement Program, or the ARM program. I was on a camp out in northern Minnesota, and we happened to be involved in a derecho, so a very strong straight line wind event. And just the sheer power and the trees were all flattened on hillsides and things like that. And it really just made me wonder, okay, how could something in nature generate this much force? So I really got into weather, went to University of Oklahoma for my graduate work, and studied tornadoes and more severe weather. ARM operates a number of different instruments at fixed and mobile sites around the world, and our goal is to really improve our understanding of the atmospheric processes. So we send these instruments to areas where scientists have particular questions about phenomena in our atmosphere. We collect the data, we bring that data back, and then we share it with scientists so that they can better understand our atmosphere.
How does equipment like this help us sort of get to understand the climate and help us get to prediction?
Essentially, when we deploy equipment like this to areas where we have specific questions, so tornado genesis, for example, we can deploy an instrument like a radar that gives us unprecedented spatial and temporal resolution. And we can penetrate through clouds. We can really understand what's going on inside, not just the tornado itself, but around the tornado, what's causing some of these dynamic processes to occur. Then scientists can take a look at that data, really understand that, and then try and build those into models so that we can better predict when events like this will happen in the future. And then send warnings out to people, and then that saves lives and property.
So is this a system that is, like if I were to turn on the news and see the weather report and I see the radar the radar visualizations, is that the kind of radar that we're talking here, or is it a different type of radar?
So in general, theory and operation, yeah, for all practical purposes, yes, it's very similar to what we see on the news. However, this radar operates at a different frequency, and so it's really looking at some different phenomena. So one of the frequencies is actually two radars behind us. One is an X-band, which is going to be looking at precipitation and hail and some of those larger hydrometeors. The other radar is a Ka band, so 35 gigahertz, and it's going to be looking at clouds, primarily clouds and ice particles, which is a little different than what you would see on the news.
So is it looking at like the density of clouds in the atmosphere, or their location, or all of the, or the amount of water content in the clouds?
All of the above. So it's really interested in the entire process for how these clouds are forming, how organized they are, how dynamic they are, how they're moving. And in addition, we also have polarimetric capabilities, so we can tell more information about the types of hydrometeors that we're looking at, whether it's a particular type of species of ice, hail, really fat raindrops, smaller cloud particles, things like that. So we can discriminate between the different hydrometeors.
Okay, so it's collecting data, probably 24/7, wherever it is.
That's
Where
right.
does that data go, and what happens to it? I mean, you're probably not sending me raw data, are you?
No, unless you want it. Then we can provide that. But yeah, generally we take the data and then it goes to the ARM data center. And this is available for anybody to download and do science with. And a lot of times we're creating products. So it might be a product that somebody could compare directly with a model or incorporate into parameterization scheme, things like that for comparison. This system's been in Antarctica. It's pretty cold there, pretty dark, pretty cold. And next we're sending it on a ship into towards the North Pole, so the Arctic region. So it's our cold weather system. So yeah, I'm sure it's wanting a vacation, it's wanting to go somewhere warm.
Tropical.
Yeah.
What would you say is the most interesting deployment that you've been to, and sort of why? Is it scientific, cultural, geographic?
For me, Ascension Island was the most interesting, particularly because of the geographic, the variety of zones that were there. They had a rainforest at the top of the mountain because it's basically in clouds all the time. There's tropical beaches, and then there's portions of it that are volcanic wastelands that look like Mars. Wow. So yeah, just such variety there, and yeah, it was a really unique place to go to.
Very cool.
Yeah.
Very exciting. Wow, that was really, really interesting talking to Brad, and I learned a couple of things from him. One thing I learned is that if we want to understand our planet and the world around it and how it's changing, we need to get out in it, observe it, measure it. From those measurements, we can then collect a lot of data and use that data to understand how our Earth's processes are occurring, and we can provide that data to the scientific community at large for their own research. And then the last thing I learned is that, at least in this area of science, you get the opportunity to travel around and see the four corners of our planet as he did, and be exposed to different cultures, different climatic systems, and different scientific challenges and questions.